Hello guys, in this video we are going to be looking at the solutions to second order homogeneous differential equations which have distinct and real roots. Okay, so in other words, we are talking about roots that are not repeated. So let's begin with this particular problem. So to solve this problem, y prime prime minus 5y prime minus 14y equal to 0. So the auxiliary equation is simply s square minus 5s then minus 14 equal to 0. So remember how I got the auxiliary equation. Just replace y prime prime with s square, then replace y prime with s and replace y with 1. Okay, so this is the shortest way to get your auxiliary equation. Anytime you see y prime prime, replace it with s square. You may be using another variable for your auxiliary equation. You may be using m, you may be using lambda, you may be using r. So these are, there are in fact a plethora of choices to use for your auxiliary equations variable, but I love using s, not just because of Laplace transforms, but I love using s because it's quite reads a lot of meaning into the nature of auxiliary equations. Now you get to discover that later on. So when we solve these auxiliary equations using quadratic formula, we have s is equal to, our b term is minus 5, so minus 5 plus minus the square root of minus 5 squared. Then we'll have what? Minus 4 into a, then c is negative 14, then over 2a, which is 2 times 1. So we are going to have s to be 5 plus minus the square root of 25, then plus 14 times 4. Thank you very much. We have 56 and all over 2. So this gives me 5 plus or minus the square root of 25 plus 56 is what? Is going to give me what? Thank you, it's 1 all over 2. So we are going to have 5 plus or minus 9 over 2. So when we solve, we'll have s is equal to 5 plus 9 over 2, or 5 minus 9 over 2. So when we solve, we'll have s1 to be 5 plus 9, 14 over 2, 7. Then s2 is 5 minus 9, negative 4 over 2, which is negative 2. So we have gotten s1 to be 7 and s2 to be negative 2. So you have to recall, okay, for s equal to s1 and s equal to s2, from our characteristic roots, we'll have y to be c1 exponential s1t plus c2 exponential s2t. So we're just going to plug it into this general formula. So y is equal to, in this case, c1 exponential, we'll have 7t, then plus c2 exponential. What do you have? Exponential negative 2t. Is that okay? So this is going to be your general solution for this differential equation with a homogeneous differential equation with distinct roots. So let's look at another problem, and that will be it. So for problem 2, we have y prime prime plus 5y prime plus 6y equal to 0. So the auxiliary equation is simply s square plus 5s plus 6, okay, equal to 0. So when we solve the auxiliary equation, we're going to get s is equal to minus 5, okay, plus or minus the square root of 5 square minus 4 times 1 times 6. So a is 1, then c is 6, then all over 2a, 2 times 1. So this is minus 5 plus or minus the square root of 25 minus 24 over, what do you have? 2. So we'll have s to be equal to minus 5 plus or minus 1 over 2. So this gives me s is equal to minus 5 plus 1 over 2, or minus 5 minus 1 over 2. So we have s1 is equal to minus 5 plus 1 over 2 is negative 4 over 2, which is negative 2, and s2 is equal to minus 5 minus 1 is minus 6, and minus 6 over 2 is minus 3. So we have s1 is equal to minus 2 and s2 is equal to minus 3. Therefore our y is a exponential minus 2t plus b exponential minus 3t. Okay, so you could use any arbitrary constant you want. If the independent variable is not specified, I'm using t in this case. Sometimes you can want to use something like c1 exponential minus 2x plus c2 exponential minus 3x. So if the independent variable is not specified, feel free to use maybe either x or t, because those ones are much common, but I'll recommend we use t, okay, while solving almost throughout our course in second order differential equation. So thank you for watching this video. Please like, subscribe, share, hit the notification to stay updated, and stay well till the next video.